Now I want to define a metric space. What is a metric space? So you will say a non-empty set X along with a function D defined from X cross X to R is said to be a metric space if it satisfies if D turns out to be a metric. What did I say? I said a non-empty set X has to be non-empty along with a function defined from the Cartesian product X cross X. The element of Cartesian product look like an ordered pair A comma B, where the first element belongs to the first set and the second element belongs to the second set. So a non-empty set with a function defined from the Cartesian product of X with X to R is said to be a metric space if D, this function, turns out to be a metric. And here we call D as the distance function. D is called the distance function. So if this function turns out to be a metric, then we say that X with this D is a metric space. And that means, what does it mean that D turns out to be a metric? That means D defined from X cross X to R satisfies following four conditions. So first condition is non-negativity. That means for every x and y belonging to X, D of xy should be non-negative. This is the condition of non-negativity. Number 2 is identity. That means if distance between X and Y is 0, then that means X and Y both are equal, and vice versa. That is, if X and Y both are equal, then the distance function gives the value 0. Now third condition is symmetry. That means for every X and Y and X, distance D of xy should be equal to D of yx. That means interchanging the values does not changes the interchanging the elements of x cross x does not changes the value. D of xy should be equal to D of yx. And fourth one is triangles inequality. Which means for every x, y and z belonging to X, distance between X and Y is always less than equal to distance between X and Z plus distance between Z and Y. If a metric, if a function D satisfies all these four properties, then we say that D is a metric on X, and hence X with D is a metric space. When I say a metric, that means for a different function, if that function satisfies these four conditions, then that also turns out to be a metric on X, and X with that function will be another metric space.